We put a lot of trust in technology to make our lives safer, easier, more efficient. But what if that very trust is creating a new, kind of invisible danger? Let's dive into the surprising story of the automation paradox.
It all starts with this number, 20. In one study of aviation maintenance incidents, 20 serious safety failures were all traced back to the exact same type of human error. Yeah, 20 times. And this wasn't because of a broken part, it was a breakdown inside the human mind.
So what was this hidden factor? It's not about carelessness or people not having the right training. Nope. It's something much more fundamental to how we all interact with the world, especially when things get really complex. The answer is a concept called situation awareness.
To put it simply, situational awareness, or SA for short, is basically just knowing what's going on around you. But it's more than just seeing things. It's about understanding what they mean and, here's the key part, being able to predict what's going to happen next. It is the absolute bedrock of good decision-making when the stakes are high.
Okay, so this whole awareness thing sounds a bit abstract, right? What does it actually look like when the pressure is really on? Let's take a look at a real-world example to make it crystal clear.
Think about a firefighter running into a burning building. They aren't just spraying water at flames. They are constantly building this incredibly detailed mental map. They're reading the smoke, they're understanding the building's layout, they're assessing every single person they find. This constant flood of information creates a rich, dynamic picture in their head. That is high-level situational awareness in action.
So, seeing how easily our own human awareness can fail, it's only natural that we turn to technology for help, right? The goal is pretty simple. Let's create tools that help us see more, know more, and make better decisions.
And that's where things like electronic flight bags for pilots came in, replacing stacks of paper manuals with digital info. Or think about augmented reality for drivers, projecting key information right onto the windshield. The idea was that these would be our ultimate cognitive co-pilots.
And at first, it looked like a total home run. Studies on pilots using those electronic flight bags showed exactly what you'd hope for. Their response accuracy shot way up, and, this is crucial, their overall situation awareness wasn't harmed at all. The tech was helping them do better without dulling their own skills.
The promise here was just huge. Research into augmented reality for drivers was saying the same thing. The thinking was, if we can make the car's brain more transparent, we could improve the driver's own awareness and build a better, more trusting relationship between the human and the machine. It really seemed like we'd found the perfect solution.
But, and you knew there was a but coming, right? This is where the story takes a really sharp turn. The very solution we built to help us started creating a brand new and much sneakier problem. This is the heart of the automation paradox.
Now, on the surface, everything looks fantastic. As we add more automation, from simple cruise control to crazy sophisticated autopilot systems, our overall performance gets better. We make fewer little mistakes, we're more efficient, our workload goes down.
But there's this hidden cost. When we hand over control, we can become these passive observers. And research shows this makes us way worse at spotting when the automation itself messes up, like an automated car just blowing right through a stop sign. We're physically in the car, but our minds aren't really there.
And there's a name for this. It's called the out-of-the-loop phenomenon. As the system does more and more of the work, our brains kind of check out, losing that deep, active engagement. The real danger is that when something goes wrong and the system suddenly needs us to jump back in, we're coming in cold. Our situation awareness has just evaporated.
And what's so fascinating is how our trust in this stuff works. Studies show that when we think a system is kind of shaky or unreliable, we want less automation. We want more control. But the second a system seems flawless, we are more than happy to just hand over the keys completely, which ironically makes us even more vulnerable to that whole out-of-the-loop effect.
So, okay, if this whole situation awareness thing is so important but also so fragile, how in the world do you even study it? How could we possibly know when someone is in the loop versus when they've already checked out?
Yeah, that really is the million-dollar question for researchers. Because you can't just tap someone on the shoulder and ask, hey, on a scale of 1 to 10, how aware are you right now? It just doesn't work that way. We needed objective, real ways to see inside the mind while it's working with these machines.
So the answer, it turns out, is to read the body's own subtle signals. And the tools researchers use now are pretty amazing.
They use eye tracking to see exactly where we're looking, they measure tiny changes in our heartbeat, they monitor skin conductivity for stress, and even look at brain activation patterns. It's like they've put a cognitive dashboard right on the human operator.
And get this isn't some far-off sci-fi concept. By feeding data from these sensors, especially eye tracking, into machine learning models, scientists can now classify a person's level of situational awareness with up to 90% accuracy in real time. We can finally actually see the invisible.
So now that we can actually measure awareness, we can start to solve the automation paradox. And the future here, it isn't about choosing between human or machine. It's about creating a real, genuine partnership.
And this really brings us to the key takeaway from all this research. We don't need less automation. We need smarter automation. We need systems that are smart enough to realize when our awareness is fading, when we're falling out of the loop, and then adapt to pull us back in. And that leads to a whole new design philosophy. Future systems have to be flexible. They need to adapt to our personal preferences and how reliable we think they are. They have to be designed to be good teammates, sharing information clearly through what experts call ecological interfaces, basically displays that show us not just what's happening, but why it's happening, making the system's thinking visible to us.
When you put it all together, the goal is to use this tech to create this incredible virtuous cycle. Better interfaces lead to better awareness. Better awareness reduces our mental strain. And this whole system can be used not just for experts, but to help train the next generation of pilots, drivers, and operators way more effectively.
And that leaves us with one last really critical question. This whole automation paradox has taught us a powerful lesson. Simply making a machine smarter isn't enough. We have to design these systems with a deep, deep understanding of the human mind. Because as technology takes on more of the doing, our uniquely human job of understanding becomes more important than ever. The real challenge isn't just building smart machines, it's building systems that help all of us stay aware, engaged, and ultimately wiser.